We're asked to construct a confidence interval for a mean. So with any confidence interval, it's always the parameter you're trying to estimate. In this case, it's a mean. And it's plus or minus the, plus or minus, oh, let me type that, okay. You get plus or minus the margin of error, okay? And so the margin of error, that's usually done by taking some sort of like distribution number, like a t distribution number or a z distribution number. In this case, it's a t distribution because we're talking about a mean, and we only have the sample standard deviation to start with. It's a t value that corresponds to whatever confidence level we want times the standard error of the parameter. In this case, it's the standard error of the mean. So if you remember, the standard error of the mean is the sample standard deviation divided by the square root of the sample size. That's basically what we want to get out of Excel, is we want to punch all this stuff in. Okay, so let's copy. Wait, I don't think we need to copy over the data. The mean is 49.88, the standard deviation. So they've already given us the mean, standard deviation, got the sample size. We just need a t distribution from Excel, I think. We need the t distribution value because we have S, we have the mean. The mean is 49.88. We have that S is 21.24. So let's see if I remember it. Equals t dot in dot 2t, I think is what we need. The t dot inverse dot 2t is a way of getting a t value if you put in an alpha value. Like in this case, our alpha is going to be 0.10. And the reason why I'm putting in 0.10 because alpha is the percentage that's in the tails. If you want to have 90% confidence, then you want to have your test statistic fall in the middle 90%. That means there's 10% left for the left and the right tail combined. So alpha is the amount left over. It's like 100% subtracted by your confidence level. And then the second part of t.inv.2t is the degrees of freedom. There's 20 data points here. So when you're doing a confidence interval for a mean, the degrees of freedom is just n minus 1. So 20 minus 1 gives us 19. So that's our t value. Okay, so I think we've got everything. So to calculate the margin of error, which is this stuff right here, I'm going to type equals, and I'm going to get my t value. It's in cell B4. I'm going to multiply that by the standard deviation. They tell me it's 21.24. I'm going to divide that by the square root, so SQRT, of the sample size. There's our margin of error. So to construct the confidence interval, we can do it with a calculator, or we can do it. We can make Excel/Google Sheets do it. The lower bound, I'm going to type equals, and I'm going to take the mean, which is in cell A8, and subtract it by the margin of error. In the upper bound, I'm going to take the mean, A8, and then I'm going to add the margin of error. Okay, I've got my lower and upper bound, so 41.67. The other thing I'm wondering about is they gave us 21.24. They rounded off that standard deviation. I wonder if it's still going to accept. Otherwise, we could just grab the data and calculate the standard deviation. No, it's okay with that. Okay. What's the margin of error? We need to calculate the margin of error in order to construct the confidence interval. Right there, like we said. What is the confidence interval using the given population standard deviation? So in part C, they say the population standard deviation is 22. So back up in this calculation, I'm going to click it, and then in Google Sheets or Excel, whichever one you're using, just erase the sample standard deviation and put the population standard deviation in. Oh, sorry, no, there's going to be something extra. Look, we use T if the sample standard deviation is being used. We use Z when the population standard deviation is known. So we can't use this T distribution anymore. Now we need to go get something from the Z distribution. So we're going to type equals Z.in.2t. I don't know. It doesn't look like that's going to work. maybe it's norm. I might have to look this up. Norm.inv. It doesn't have two-tailed though. No, okay. But we can get it from the z distribution. It's going to be a little different. Equals norm.inv. It doesn't have an option for two-tailed values. So when I punch in my alpha, I'm using 0.05 because it's only giving me left-tailed values. There's 5% in the left tail and 5% in the right tail. Oh, that didn't work. Okay, I got to look it up. Okay, I tested it to make sure it works. So you get z value. Oh no, I forgot already. Equals norm. Here, I got it right here. Norm.s.inv. I don't use Google Sheets and Excel too often for statistics, so I got to look this stuff up sometimes. So norm.s.inverse, norm.s.inv is a way of punching in a probability, and it will spit out the corresponding z value. And that's what we want when we're constructing a confidence interval. We want a z value that corresponds to our level of confidence. But the same thing applies for what I was trying earlier. This function in Excel is only giving you left-tailed values, so you don't want to plug in the entire alpha. You only want to plug in the left-tailed alpha to get the right z value. You'll see that it's negative because that's on the left side of the distribution. But when you construct a confidence interval, the margin of error is plus or minus, right? So the negative value cancels out anyway. You could just flip the plus or minus symbols around, you get the same thing. So we'll want to keep that in mind too. Margin of error, same formula basically. So I'm going to type equals, I get my z value, and I multiply that by sigma, which is my population standard deviation, and then I divide by the square root of the sample size, so divide by the square root of 20. So there's our margin of error. We just want the positive version. So equals absolute value, a quick way of getting positive. Okay, so we got the margin of error for the new confidence interval, so we want to construct an upper and a lower bound, just like we did before. And the upper bound is found by taking the mean, which I think is still A8. And then we want to subtract the margin of error using the z distribution, the A8 plus the margin of error. And that's what I got down here. Okay. We use z when the population standard deviation is known. But in practice, you almost never know the population standard deviation. That's why we use t a lot more.